I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by David Kerr, President Humanoid Robotics Schaeffler. On today's episode, we'll dig into how Schaeffler is positioning itself in the emerging humanoid robotics market and what it will take to make humanoids viable in the real world. We hope you enjoy this episode. Dave, welcome to the podcast. And I have to say, humanoids are cool. So I'm excited for today.
No, happy to be here. Thanks for the invite.
When did Schaeffler first enter the humanoid industry? Because I've been studying the humanoid industry, and I have to say, your team did a wonderful presentation for Bank of America. It was absolutely fascinating. I learned a lot of that. It seems that I'd watch a science fiction movie with my daughter, humanoid this, and all suddenly it's become an industry that's on a rocket ship to the moon.
Schaeffler became involved. I think it kind of grew organically by the components and the products and the systems that we're involved with on the industrial and automotive side. So this happened over the last couple of years, but really in the last 15 months, we've dedicated an organization and put a special setup in that organization to get this up and running.
The organization was set up for the last 15 months. When did an internal team or yourself start to see signals that, wait a second, this could become a pretty big business for us? When did you start to see those signals emerge?
The signals, I believe, have been there for 5 to 8 years that this physical AI would start to become more mature. So we knew that we had to wait, or we knew that there would be a waiting period where there was a lot of development needed to bring that kind of technical maturity that would really enable physical AI. So Schaeffler uses a lot of industrial robots and cobots, and those are getting more advanced by the day as well. And it was just a natural lead into humanoid. So I would say at least 5 years. And there's different parts of our organization that may have been contributing already for prototypes or bearings to these special projects, at least for 5 years, maybe even a little bit longer.
Do you think one of the advantages of your organization or your company is the insight into the supply chain? And so you're able to see potential new trends emerge just because if you look at the overall supply chain that your company has access to?
Definitely, that is a part of it, but we're also a user of these type of bots. And this really gives us the insight because we understand where we have gaps or where we would like to utilize these bots inside of our own organization. So that's where it really starts. And then when we talk about scaling, then certainly our supply chain and all of our 80-year history with industrial applications and automotive applications come into play as well.
So you've been in this division for 15 months. How has the thinking changed from day one to today? And then if I looked for 15 months from now, we're probably having a whole different conversation. We're like, yes, we've got 100,000 deployed and we're deploying thousands a week.
It has changed, and mainly for the positive. When we started, and my main responsibility is on the supply side. So certainly we're in tight cooperation with our plants and our advanced production technology folks who have to deploy it. So this is the benefit of being at Schaeffler. But the last 15 months, I would say that when we started in January of 2025, we weren't as ambitious as we should be. And so we laid out some goals, especially on the supply side, to get some sample orders, and we exceeded that. I think the number we put out there, we exceeded by about 500% in the first year. So one thing that we understood is we need to think bigger. We need to be ambitious, and this thing is moving much faster than many of us with the automotive background have seen before.
But the really interesting with the automotive, with the background of your company, is that I don't want to say the two worlds are merging, but you're seeing global OEMs deploy robotics as we've seen, and now you're starting to see humanoids be deployed on the lines. Is that a trend? So you're seeing it in Singapore, you're seeing it in the US. Do you see that trend continuing? You're also seeing it in Germany as well.
Yeah, I do think that trend will continue. I think much like our motion technology portfolio is a natural fit for humanoids, there's a lot of work in autonomous driving. And I think that correlates quite well when you talk about designing, developing, and industrializing a humanoid robot as well. So I believe you're seeing some big companies already involved, like Tesla here in the US, or in China. Some of the big companies like Xiaopeng and Xiaomi have already announced that they're going to start with humanoid development. And so I think this will continue, and I think you'll see some more OEMs pop up.
I think this is just an assumption on my part, but I think it's just a matter of time until every major OEM has a humanoid program. Either they build it internally or they acquire it. You mentioned goals. Does weight play a goal with the actuators as it comes to reducing weight? Are you, when you're setting your goals, are you looking at the entire humanoid? Obviously, you have the cost structure, you have the weight, you have the dexterity. From a goals perspective, are you looking at all of those things to the parts that go into the humanoid?
Yes, we're looking at all of those, and then you have reliability that you put on there. So if you really lightweight things, which is better for efficiency, it's better for increased payload of the humanoids. You cannot sacrifice reliability. So the parts still have to function over a certain period of time that's expected. So all of that has to be managed.
And then a buddy of mine, ARI, they just recently were acquired by Meta, and we running their software on a Unitree. And he said, try and knock it over. And I push it. And it was incredible. And I'm sitting there and he goes, no, push harder. I said, I don't want to break your toy. And he, push harder. And these balance that it had, that was pretty amazing. How is when they call it steady as you go balance achieved on these humanoids?
Yeah, I mean, it's a complex AI that is coming from the OEMs, these AI stacks that are able to compensate that and compensate it in real time, which means extremely fast, much like a human. So there's been a lot of AI advances, and the OEMs would be able to speak more of how that actually works than we do at Schaeffler. But obviously, our actuators would also have part in that. But this AI stack is commanding our actuators to move, and we move. And these commands are quite fast with these calculations that are occurring inside of the AI stack from the robot.
From an actuator perspective, what type of testing are you doing? Are you putting these actuators through pretty intense testing? What type of testing are you doing?
We do functional and performance testing. So in some cases, we get specs from OEMs and they say, hey, look, this is how we want you to test them. With a lot of these OEMs, we talk a lot about collaboration, and that's because we're all on a learning journey. There's no internal combustion engine cycle that we run that is pretty standard in the industry. This is all quite new. So we run some durability tests as well. We've modified our durability tests through discussions with some of our OEM customers that prefer, maybe higher speeds or more actuations in a shorter amount of time. We've modified that and tried to stay up with the latest thinking and research coming from the OEMs, and then also what we're learning with our own development.
Well, then that raises a question that I think a lot about: dexterity. How much research internally are you doing around dexterity?
So we are doing a lot of, I would say, research. We are building prototypes of different configurations. So not just human-like hand with 4 fingers and a thumb, and understanding what we need for our own use cases. So most of our studies, most of our piloting has been around what we see as our needs inside of our factories. From a supply side, we're engaged with a lot of customers on what components, what kind of small actuators are needed, and what are the requirements for those components. So it's really twofold. What do we need, and what are our customers asking for?
How are you planning to deploy humanoids in your factories? What tasks are they going to do? And I'll use the warehouse term. Are they going to live in a cage? Are they going to be open? What is that going to look like?
So certainly we have to get away from them living, I think you used the word cage, or behind fences. And today we have pilots running that we do put behind, let's say, glass walls or fences for safety reasons why we're piloting them. But in order for those to be effective, especially cost effective, they need to come out from behind the fence. Definitely that is where we need to get here in the next months and years to come.
Is one of the reasons why you're deploying the humanoids in your factories to get real world data, because we're seeing a lot of acquisitions now of humanoid companies. And I'm the guy that reads the fine print in the SEC filings and the releases, and I've noticed a common trend: real world data, and it's popping up consistently. Is that one of the reasons why you're deploying them? Obviously you have the efficiencies, but is it to get that real world data that you cannot necessarily replicate?
Yeah, it's a great question. So with real world data, this is a key to today's training of robots. So real world data is important, especially today. Why we're deploying the bots is that we see a certain gap that is coming in the workforce due to demographics. So our world is getting older as a population, and there's a missing workforce. It's missing today. If you look in the want ads for job openings in the cities where our plants are located, you will see Schaeffler is normally advertising for workforce, for new team members. And so humanoids will fill part of that gap, and that gap, by many accounts, is expected to get bigger. So we see this as necessary for Schaeffler's competitiveness to go all in on humanoids. Certainly, when we deploy them, we capture data, but even before them, if you talk about real world data, We do a lot of real world data in the lab, for example, with teleopting, where you have a human that is basically a mirrored approach with there's different ways to do this, even with gaming consoles and VR glasses that you can teleopt robots. And this is how we're generating our own real world data for our training and deployment purposes.
So I'm going to put on I'm a weird geek hat. I've played with some of the DeepMind data sets for robotics that have been available on Hugging Face. And you just see basically, hundreds of times trying to grab a ball, move, let's just say block from here to there. And is a task like that as well from what I've played within that data set?
We've identified 6 main use cases. And why 6? Well, these are the 6 use cases that we find at nearly every one of the 100 manufacturing plants at Schaeffler. And these go from line feeding, line tending, logistics, assembly, packaging, and inspection. And so you can find these types of use cases at nearly all of our plants. And why that's important is we don't want to develop a humanoid concept or a humanoid deployment that is good for just one plant. We want to develop humanoids and really any kind of manufacturing physical AI where we can deploy that across many of our plants.
Well, if you look at, I would say this is a common denominator across all of your plants and probably every plant around the world. Boxes. A lot of stuff gets shipped to plants. Can the humanoids open the box yet?
I believe in lab scenarios, yes, they can open the box. This is certainly a bit tricky, but in the lab scenarios, they can. I don't know if they're completely reliable to throw out on the manufacturing floor. A lot of our customers, even in automotive, they're trying to get rid of cardboard boxes. I mean, this brings the risk of contamination. This is a lot of waste. So we also deal with a lot of returnables. And inside of our plants, we really put a premium on returnables. So we have similar totes, similar trays that we use across the globe so that when we do design automation, for example, we do design assembly lines, they're designed around, I would call them these Schaeffler standard totes and trays.
Which is wonderful. It's good for the environment, but it also allows you to celebrate. I'm curious, you mentioned a little bit earlier around the aging population. And you can't talk about aging population without Japan and the policies put for the Japanese government. And then last week we had a report from JAL, the airline, where they're starting to deploy humanoids. Based on government policies, different publicly available aging data, do you see humanoids being adopted in certain countries faster than others, just based on the purely on the demographics?
I think demographics will play a big key in that. So even if there's policy against that or for that, I think the demographics will force the hand that they will need to probably deploy not only humanoids but other techniques, especially in some of the countries where this population decline, or at least the age of the population is increasing so rapidly. I think this will naturally happen, that it will drive a need, and this need will drive change if the change isn't already there.
There was an MIT study years ago. This is pre-humanoids, where they put I want to call a desktop robot in a home, and it would remind elderly individuals, okay, today you have to take your medicine, and the doctor's going to be calling you this time. It would those little reminders, and they put the little eyes on it, and it became part of their lives. And some of the studies were that it could increase their life because they weren't depressed and they were happy, which raises the question, do you see humanoids eventually going into senior citizens housing and going into homes just based on what we purely saw in the positives that came out of that MIT study?
Yes, I think that will happen. I'm not a doctor. I'm not an expert in this, but if you're asking my personal opinion, which I think you are, yes, I was at an event last week where they were talking about an Alzheimer's study where they had robotic dogs, and these didn't even have, let's say, legs. It would not walk around. It just would sit in the laps of elderly patients that had Alzheimer's. And this brought around some benefits, that they were happy. They felt like they had a companion. There was somebody responding to them. And so, yeah, I definitely think that this will be in the future.
And then do you think that also goes into the traditional home where with young kids and dogs? Obviously there's companies that are out there very publicly talking about wanting to deploy that. Do you think that's going to happen? And if so, how close do you think we are to that reality?
That is a great question. It's coming for sure. I'm not sure of the exact timeline. I'm not sure anybody is. There's some brave companies that are pushing in to this home world, and there it's so unstructured. Unlike a plant or a logistics warehouse, it's going to be very unstructured. So we're keeping a close eye on some of these companies then that are deploying. How much teleopt, how much intervention are they going to need? How is the customer getting frustrated because it's not doing exactly what was expected, or are these things working incredibly well? And is this going to accelerate deployment into the homes? We believe as a company that home use and healthcare will come a little bit later, after manufacturing, after logistics, and there will be service industries, greetings, working showrooms. Especially if you look to China, they already are deploying a lot of humanoids in the service industry.
No, I agree with that, Tim. I think at some point, and as similar to you, I won't give a timeline, but at some point they will go into homes. And I think of spend a lot of time talking to law enforcement officials, and I think of weird edge cases. And I've asked a lot of humanoid companies this edge case, and I'd love to get your opinion on it. I said, you have a pool edge case. If some kid thinks it's funny to push the humanoid in the pool, what's going to happen, and how are you going to get it out? Because they're heavy at the end of the day.
That is a good question. I'm not sure I'm qualified to answer, but there's going to be a number of these kind of scenarios that we didn't think about before. Certainly, some of these companies will already get experience with these wheeled robots that are tooling through cities, delivering pizzas or delivering packages. So I've seen news articles and stories where there's some abuse of these robots. So I'm sure that the smart folks in Silicon Valley or wherever in the world will develop some deterrence to do this.
And perhaps you could see a new business emerge. Humanoid rescue service, just like the tow truck comes to get your car in the old days. But the bottom line with Schaeffler is that you operate in this humanoid ecosystem. You have a vast amount of partners. What are some of the key strategic learnings that you've had from the interactions with your partners?
I would say that most of our interactions have been a bit different, which is great. This is what we want. And I hope that they also see that with us, that maybe we're a different company or a different supplier than they're used to. So what we learned is everybody's speed a little bit different. They all have a unique, let's say, target that they're aiming for. We try to partner with companies that are not doing the same thing as the other companies we've already partnered with. So if we have somebody really focused on logistics, maybe we need to find one on assembly or find one on inspection, and so that we get more well-rounded and we see how the technology is coming along, not just in one type of use case, but multiple use cases. And so we learned that the world is spinning faster. I think, at least it feels like it is. And we talked about that before we got on the air here, that it is really accelerating. And so you see different paces between the different partners as well. And what's really unique is that even if it doesn't start out as a completely open relationship, because these are most of the time new customers to Schaeffler, over the first few months, then you develop a much more open relationship. The engineers at Schaeffler and the engineers at the OEMs really start feeding off each other. And this is where growth comes. This is where accelerated technology deployment comes.
If you look at the vast ecosystem, the growing ecosystem, and you take Schaeffler's willingness to learn from different segments, have you seen any inbound interest or actually any deployments of putting humanoids into maritime on some of these large tankers or some of those tasks?
Where we've seen that in maritime was more shipbuilding and some of these, let's say, less ergonomic friendly, where they're welding, they have to crawl down into tight spaces and do welding. So we even have a partner that is focused maybe on these heavy industries and supporting that. So I personally haven't seen any working on ships, but anywhere where there's, somebody once said there's 3Ds, dangerous, dirty, and dull jobs, which humans either shouldn't be doing or don't like to do, this is where we will see physical AI and humanoids pop up.
You bring up a fascinating point about welding. I was in Las Vegas yesterday and I saw a welding school. And so you think about that's a skill, and it's a hard job for a lot of individuals. So it's interesting when you really think about all the opportunities. So you have you have the physical opportunities, and then you're training the robots to learn, but then you also have the acceleration on the digital side. And Schaeffler has a partnership with NVIDIA and using their Omniverse platform for digital twinning. What does that unlock for you? Is that accelerating what you're building?
Definitely. It accelerates it, not even in the spirit of just deploying humanoids, but in general of mapping out new work centers, new production lines. We do all of this virtually now. So we engineer our production areas now virtually. And when we have the models coming from NVIDIA and we put it into their own omniverse where we then can simulate humanoids, we are optimizing and engineering this before we even put any kind of metal on the floor. And this provides a huge time savings instead of doing everything on paper and then hoping or expecting from previous knowledge that you're doing something right, procuring all the equipment, putting it together and finding out, oh, this doesn't work exactly like we had planned. So a lot of that, you're closing this so-called simulation to real gap, that you have simulation. We're using this with the tool chain from NVIDIA. We're creating everything we can before we have to actually put equipment on the floor. And the time then to deploy once the equipment gets to the floor is significantly reduced.
How did you get, or how did the employees buy into this? To me, it's a great tool to accelerate. One, it lowers cost, and two, you can make a better, superior product. Historically, you've seen some companies that don't want to buy into it. How did the staff buy into it?
The staff enjoys it because then you can get creative. You can also, or you will need to open your mind to thinking a bit differently, trying new things, because it's a lot more cost effective to try something virtually, have it fail 10 times, and find the one way that you say, oh, I didn't think of this before, but this is really optimized and it's completely different than what we had done in the past. I think this is where people get excited about using these types of tool changes, that it gives you this freedom and you know that you're going to do something. And even if it's a little more complicated, for example, and sometimes it might be simple, but even if it's more complicated, you can try this. And then you have the knowledge that, hey, you've already simulated this. So when you put the equipment down, even if it is complex, that you've already tested this out and it will work.
It's great because then, to me, you can let your imagination run wild in the digital realm, and then you can get it to a point where when you get back to the physical world, you can deploy it. In the physical world, there's actuators. They account for roughly 50% of the robot's bill of materials. How is the company working to bring these costs down for actuators?
This is where an area where Schaeffler excels in, because we've been doing it on the industrial side and certainly on the automotive side, is scale. So we love scale. We have different techniques for doing this, and we can rely on our DNA from automotive and industrial. So in a lot of areas, what might be machined components today, Schaeffler is great at forming. And so we would rather form the net shape than machine everything. And this is where you get scale. Instead of taking 2 minutes apart to machine in teeth or gear teeth, for example, we can form them in seconds. And so these are the types of things that Schaeffler brings to the table. We have another bearing that's specifically designed for humanoid actuators, and we introduced this last year. And then this year we came out with a formed version. So at the end, if you looked at the parts, you really won't see a difference, but the main ring, so the inner and outer ring, are formed now. And what this does is cut out a lot of milling and machining operations in the middle. And so you save time, the manufacturing costs come down, and you're able to scale faster.
From your perspective, what advantage does Schaeffler's automotive background give the company as you accelerate into the humanoid industry?
Bringing some of these automotive style manufacturing and design for manufacturing experience into the components that we're designing for humanoids is one of the biggest ways that we benefit from our automotive DNA. These are things that we've done the last 80 years, and we've gotten progressively better, progressively more efficient. And this has really honed how we do our manufacturing. We have what we say 12 core manufacturing technologies that we focus on. And all of these were honed either on industrial or on the automotive side the last 80 years. And this gives us a big advantage because we're also quite vertically integrated, nearly 100% vertical integrated for the complete actuator.
Which makes a huge difference. So you're the part supplier, but you also act as an integrator. So I'm really curious, what does it take to successfully, safely integrate a humanoid into the workforce and then to a factory? Like, what has to go into that?
There's a lot of work that goes into that these days, and this is going to have to speed up if we want to have the deployment in the volumes that we expect and the volumes that will be needed by industry. But it starts out now with this simulation. You mentioned the NVIDIA tools, so this is where everything starts out, and you start concepting how this will look like. This then will go into a pilot phase where we bring an OEM in, they will bring their bot in, and then we run a pilot for a specific use case. After the pilot is done, there'll be some time, some weeks or months where we go back and we analyze the data and say, how can we make this better or what has to improve? And we will bring it back for a longer run. And after that run, the expectation is that we would be able to deploy that technology.
When you analyze the data, I have to ask, how focused are you on battery life and how long it lasted? Do you pay a lot of attention to that?
Yes, because that all goes to uptime of the equipment. So this really is something that most people, when they're putting in manufacturing equipment, are also looking as what is the uptime, and do I have to buy two bots because the battery life isn't where we need it, and so they have to switch off. This is all part of the calculation. As far as the supply side, we don't directly look at let's say the battery usage when we talk about actuators, but we try to make our actuators as efficient and torque dense as possible. So efficiency is always in the back of our mind, whether we're deploying them or whether we're designing parts for them.
So then the humanoids in the field, do you have any rough estimate or any data that you're seeing for the average time a humanoid is out doing a task before it has to go back to charge?
Certainly, it will depend on what the task is. We see it that they're 2 to 4 hours before they have to charge. There's some more, there's some less. It really depends on the bot itself, the design, the maturity, and also the type of use case. But what our goal, first of all, is that let's get the uptime to be the same as humans. So if a human goes on break after 3 hours or 3.5 hours and takes a half-hour break, then it's also possible for the robots to go and charge as well. So the first step is not superseding anything the humans can do or making it better or that it's running constantly 24/7. It's can they do the same work as a human does? And so their human takes breaks, maybe an hour total in an 8-hour shift, and that time could be used to charge.
So in simple terms, is the goal basically just to fit into the workforce calendar? Is that the ultimate goal? Is that, okay, this is how it works. So you're not disrupting the flow of the organization, the flow of the factory?
The first stage is to get them to basically operate in an environment that was designed for humans. And the idea is that a human could do that job one day or a humanoid could do it the next. And that really is then gives you the kind of flexibility you need. I think the second step is how would we do things completely different? If it was all humanoids in a certain section, or are we going to want, I would say, superhuman powers for humanoids to be able to lift heavy weights, or we utilize that they can turn with a different radius than humans, for example. All of those, I would say, are second stage problems. The first stage, as you described, is just to get them to live and operate and work in the same environment as a human does.
It's coming. I think I want to highlight this because, and this is my opinion, one of the coolest things that your company indeed does is that you're a lifetime solution provider. You don't say, hi, here you go, have fun. You say, nope, we're here for you. And I think that's really great for the lifetime. So how do you plan to handle the maintenance, the condition monitoring of these robots? Because the company has an incredible track record of being a lifetime solution provider. And to me, it says, okay, Schaeffler's there for me.
Yeah, we're really cradle to grave. So we're going to deploy robots. We will supply components for robots. We have this integrator capacity also in one of our divisions that can provide assembly lines and test cells to humanoid OEMs. But the fourth part and the fourth area that you just described is our what we call vehicle lifetime solutions, or our aftermarket area. And so there we expect the first business to be being able to connect startups for humanoids with our deep and wide distribution channels, because this will be something that they don't inherently have. The second part of that is as we get more knowledgeable about how humanoids are behaving, what is their duty cycle, what is wearing out, even with our own parts, how can we do predictive maintenance? What data can we get out of the parts that we sell that can help do predictive maintenance? And so that's one area that we'll continue to develop. It's a little bit early for that. Our VLS colleagues, our Aftermarket colleagues are in contact with us. We're having these discussions already. But until these are out in the field and we really get this real world application data, I think this will take a little bit to develop. But we're certainly talking about, as we develop products, with this in the back of our mind, how could we predict, failure modes? Something's not right. This bearing seems to have a problem, just like we do in the industry and automotive worlds today.
If you look at automotive, you play a very crucial, critical role in that industry. It seems to me with humanoids, you're looking to play that same role in humanoids that you play in automotive.
it's really going to be modeled after the same things as you said, either in automotive or industry. And there's parts from both of those industries that we have a lot of experience with that we will bring into the humanoid sphere as well.
And the humanoid sphere is growing, so that raises the question, what's the next big trend we need to be watching for in humanoids? Are we going to have a custom me humanoid, a custom you humanoid? Well, what do we need to be looking for?
Also a very good question. I think a couple of things come to mind. I think safety is one thing that if you're asking for a little bit different topic, maybe not the one everybody's excited about, but it's critically important, especially for Schaeffler. We have no bigger mandate than to make sure our coworkers are safe at work. So safety, we need to develop regulations as countries globally that we're aligned on what regulations are there or need to be developed. Are there gaps? And so people are working on this today, but this will have to accelerate. So this safety aspect, I think, will be one of the important things. Maybe two other quick ones. You mentioned dexterity before. I think that dexterity, if people really solve this riddle of having really a human dexterous hand, I think this will open a lot more use cases. If this is really, truly dexterous like a human's hand is, that this will open use cases. And the final one is we need to get much faster, and I mentioned it before, much faster with being able to deploy these bots. So right now we use a lot of real-world data. We will have to rely on more synthetic data or peripheral data. Maybe cameras are watching humans do a task, and that's how you're training the robot. So really these three trends, safety, dexterity, and then the training and how we accelerate, those will be the three trends I would name to look forward to here in the future.
The industry is growing. On the safety side, you're seeing movements in Congress around policy around humanoids. There's companies that have published research reports around edge cases for safety with dogs, for example, because they're low to the ground, they're unpredictable. So you're 100% right on the safety element. I think about it, okay, if the humanoid falls over and there's a dog or a small child, if I'm going to put it in my house, you have to give me a very clear, what is this going to do? So safety is very key there, and just the overall acceleration of this technology. And I'm still waiting for the moment from Dexterity when we have that Da Vinci robot moment where all the lives have been saved because Da Vinci robot with intuitive surgical. At some point, we're going to have a breakthrough like that on humans. It'll be really interesting and fun to see, to watch. Dave, this has been an insightful conversation. I'm super excited about humanoids. As we look to wrap up today, what would you like our listeners to take away with them?
I would like them to take away that companies can transform. And you look at Schaeffler, and it's predominantly known in circles for our industry and our automotive prowess. But companies can change, and we're really lucky to have the leadership at the top that is questioned, what are we going to do next? And really jumping into this humanoid sphere, whether it means deploying them or supplying parts to them, to doing the aftermarket, or helping smaller OEMs or startups integrate. This is visionary. And so what I would like people to take away is I hope you hear a lot more about Schaeffler humanoids in the same sentences in the future.
I'll summarize this way. Schaeffler is leaning into the future. They're taking a front row seat, and they're actively building it. Today is tomorrow. Tomorrow is today. The future is humanoids. Dave, thank you so much for coming on SAE Tomorrow Today.
Thanks for having me.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next.
Be sure to join us next week as we explore how additive manufacturing is changing aerospace.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.